So we finished talking about measures of center, right? Mean and median. And so now the next thing we want to study, which is an extremely important topic in statistics, is measures of dispersion. So spread, dispersion, variation, all of those words mean the same thing. We want to look at not just what is the average or the mean, but how spread out is the data, because that can provide us with a lot of information. So dispersion is the degree to which the data points are spread out or dispersed. Okay, let's look at a quick example. It says the histograms below represent IQ scores of a random sample of 100 students from University A and from University B. So if you look at both data sets, the mean IQ score is 100. That's what we know. The mean is 100 for both. So if that's the only thing you were looking at, you would think that the student body was pretty much the same in terms of IQ. But I want to know which university has more dispersion or variation in IQ scores. So if you really dig a little deeper and you look beyond the mean, the graphs are very different. They both have a mean of 100. And I know it's really hard to see, but the 100 is right here. That's the mean of 100. They both have a mean of 100. But at University A, the low IQ score is 60, the high is 150. Whereas at University B, it goes from 80 to 120. So you can look, it's pretty easy to tell. They're more spread out over here at University A than they are at University B. And we're using a very simplistic measure of spread here. It's called the range. So in this case, because this goes from 60 to 150, which that would be a difference of, let's see, if you subtract, you would get 90. That's a range of 90. This one over here from 80 to 120 only has a range of 40. So actually the spreads are pretty different. Which one has more dispersion? Well, that would be University A. They're much more spread out. So this is the first measure of spread that we're going to talk about. It's a very simple one, and that's called range. It's just largest data value minus the smallest, or high minus low. Super simple. And they call it R. That's the letter that they give range. So if you wanted to use that, you could say that based on the range, the group with the larger range is more spread out or more varied. But that, like I said, is a very simple way to look at things. So we need to dig just a little deeper. So what we want to actually look at is we want to see how spread out the data points are by looking at how far each data point is from the mean. Like we know what the average is, but are the data points tightly clustered around the mean, or are they really spread out around the mean? Because that would give us an idea of the spread. So we're going to look at average deviation from the mean, okay? Or the mean amount of deviation from the mean. So what that's going to involve is looking at how far each data point is from the mean. So we're going to have to do a little subtraction. So we are going to talk about this thing called variance. And I know the formula looks super scary. It's really not that scary. What it says to do, we're going to break it down into parts. You take each data point and you subtract the mean, and you find out how far it is away. Well, if your data point is larger than the mean, then when you subtract, this number will be positive. If your data point is smaller than the mean, then when you subtract, this number will be negative. So you're going to get some that are positive and you're going to get some that are negative. And the way that this works mathematically by design, it always works out that if you take all these positive ones and add them to the negative ones, it all cancels out and will equal 0. Well, you can't just have 0 in your formula all the time. You wouldn't have a formula. So they went, well, we don't want the positives and the negatives to cancel each other out. What could we do so that we don't have positives and negatives? Well, one option is to do an absolute value. But that's really hard to work with algebra. So another way to fix it is if you just take the amount and square it. Because when you square things, they always become positive. So they take the squared deviations and they go, well, that'll fix it, right? We'll just square everything and then it's all positive. And we're going to add them all together. So we're going to add up a bunch of stuff and then we're going to divide. Now, it just so happens we don't divide by n, like we would with a mean. We divide by n minus 1, and it has to do with something called degrees of freedom. It's really kind of a more lengthy discussion than we normally do in this half of the course. You can read about it in the book if you want. It's called Degrees of Freedom. but it's the sample size minus 1. And that's how we calculate. This is average deviation from the mean, but they're squared. And so the symbol we use is S squared, and that's if it's a sample. So if you're doing a variance of a sample, you use an English letter, that's S squared. I'll go ahead and start filling in my table. If you're talking about a population, you need to use a Greek letter. And it turns out that the Greek letter we use is a sigma. It's a lowercase sigma, and it looks like this. It's kind of like a little whistle, and then you square it, or some people write it like that, squared. Kind of looks like a little whistle. Either way, or like an O with a little tail on it up here. So this is the Greek, and this is English letters. So the problem with variance is you just went and squared everything. So now it's too big, right? So we got to bring that back down to reality. We have to unsquare it. And the way you do that is you do a square root. So the way you get from S squared back down to S is you take a square root. Now, I could have put a giant square root on this formula, but that would have made it even look more awful than it already does. So we keep them separate. This is the one we're really going to focus on, standard deviation, and I'll explain why in a little bit. So variance is sort of a means to an end. We have to go through this formula to get to standard deviation. And you know your calculator is going to do all this anyway, so don't panic. So if you're starting to panic, don't panic, okay? Now, for standard deviation for a sample, we just use S. Again, those are all English letters. For population, we're going to say the little sigma, okay? So again, Greek, and these will be English letters. All right, so that's how you can keep them straight. So let's talk about standard deviation, because range is too simple. Standard deviation is really the one that's more used. So here's what it is. It is a measure of how the data points vary from the mean, and we say it's typical deviation from the mean. That's a really good explanation of what standard deviation is. Average deviation or typical deviation from the mean. Now, because of the way the formula is, you see how there's a square root? It has to turn out that this number at the end is either 0 or positive. Can't have any negatives coming out of a square root. 0 would mean all the data points are exactly the same. Super boring. That would be like if the class average age was 25, if every single person was exactly the same age, there'd be no variation in ages. Super boring. Outliers are going to cause standard deviation to increase dramatically. So think about it. It measures spread. If everybody's roughly 23, 24, 25 years old, then the standard deviation, the amount of variation is going to be very small. If you have some 90-year-olds walk in the room, now all of a sudden the standard deviation is like, holy cow, they're all over the place, right? These ages are all over the place. So outliers would cause the standard deviation to increase quite a bit. So you try to not have outliers. The really big reason that we like to use standard deviation is because the units are the same. When you calculate variance, let's say you're measuring dollars, okay? Then standard deviation would be dollars. Variance would be square dollars. And I don't know what the heck a square dollar is, and I don't know how to interpret it or talk about it. So we like standard deviation because the units will be the same as your data. If you're talking about the number of people going through a drive-through, so your standard deviation would be, 4 or 5, however many, whatever it turns out to be, people. Variance would be square people. Again, I don't know what's a square people. I don't know what that is. So we like standard deviation better. When it comes to interpreting it, the bigger the standard deviation, the more spread out your data is. So the bigger the number, the more spread out. When you're comparing two populations or two samples, the one with the larger standard deviation is more spread out. It's kind of the same thing. And a really good rule of thumb that we like is if your data point is more than 2 standard deviations away from the mean in either direction, either bigger than the mean or smaller, we consider it far away, and we'll define that later as unusual. But if you're more than 2 standard deviations away from the mean, you're starting to tread on unusual territory, okay? So that's sort of the setup. So now what we need to do is we need to actually calculate some of these things, and we're going to use the same data set that we used before. So I'm going to start the next video here. So if you don't have this data in your calculator, you might want to go ahead and put it in your calculator before you start the next video.